All right, so moving on to 1.2, displaying categorical data. So now I'm going to use the same app that we used yesterday with some of this information, and we're going to put it into some bar graphs, into some pie charts. The nice thing, again, the technology is kind of taking care of us, but I'm going to speak and talk about how to do the math just in case we needed to using a calculator. But we'll also show you how to do the using the technology. So objective one is to make bar charts and pie charts of categorical data. A bar chart shows each category as a bar. As you can see, the heights are either shown through the frequencies or relative frequencies, the relative frequencies being written as a percent as opposed to the actual number, not just the count. And that's relevant for us because we don't have to have the same sample size. We can use percentages of sample sizes to show that these charts. So, and a pie chart, again, is a circular chart through 360 degrees where we create these angles. So if we look at a bar chart, make sure that you look at the y-axis. If this is a count, then it would just be a frequency. If it's a percent, then that would be using the relative frequency. And as you can see, we have the data here: level of education, less than high school grad, some college, bachelor's, advanced degree, some sort of master's degree, or a doctorate degree. We can put that into a bar chart, and we can see which has the most of a certain question. Like in this, you can see that the highest bar here has some sort of college degree, and it looks like that, that gets close up to 30 degrees. Same thing with bachelor degree, look like it's at about 25%. And how we find these angles, we could find the angles if we had to create our own. So 25 degrees or 25%, okay, 24.9 is relatively close to 25%. Well, how many degrees is in a circle? There's 360. So if we wanted to find 325% of 360 degrees, we would multiply 360 times 0.25. And if we got the calculator out and entered that into the calculator, we did 360 times times 0.25. You can see that it equals 90 degrees. So we could, again, go through this and we could mark these angles at 90 degrees. Okay, so that would be a 90-degree angle to create this piece of the pie or piece of this graph. Okay, same thing with this. We just wouldn't use 24.9%. We would use 28.7% to find this angle. Okay, so if I went to Desmos and entered in 360 times 360 times 28.28, what was it, 7? I think it was 7 here. Yeah, 287, then we could see that that angle right there would be 103.32 degrees. So this angle right here is 103.23 or whatever it was. Okay, degrees. So that's how we would have to make that. Now we have the use of technology, and I'm going to show you that here in a second. Okay, so we had this example yesterday of, would you rather be happy, rich, famous, or healthy? And we wanted to enter this, and I want you to make a relative frequency bar chart and pie chart to display the data. So there's a few things that we have to be able to do for this. And we showed this yesterday. We did the 7 over 40. Okay, we did the 21 over 40. We did the 4 over 40, and we did the 8 over 40. And we were able to get that. I want to show you through technology. Again, we went to the site that I shared on the Google Classroom. We go to statistical applets and we go to one categorical data. Now, the one thing I didn't talk about yesterday is the variable name. Okay, the variable name is what we are working with. What are we working with here? Okay, we're working with preferred status. So we would put preferred status here. So this would be preferred status. and group, single, counts, and categories. And what are the category names again, just to make sure that we're all using the same ones. Famous, happy, healthy, rich. Famous, happy, healthy, and rich. Again, adding a new one, just click that button there. And we would enter in the numbers of 7, 21, 4, and 8. So 7, 21, 4, and 8. And we would begin the analysis. And again, here would be my bar chart. Okay. And right now, this is frequency. If you look at the y-axis, we wanted relative frequency is what it was asking, correct? We wanted the relative frequency. So here's a frequency table. We want to make a relative frequency bar chart. So to change this, we just click on this little button here, relative frequency, and you can see that it has changed from the count to the actual percentage. Now notice the bars didn't change at all. And if I wanted you to put this into, now you can just copy the image and we can put that into our notes here. That didn't work too well, did it? Hold on, let me see this again. Copy image. What is going on? Let's see here. Give me a second. Cut. Uh-oh. I'll try this one more time. Make this a little smaller. For some reason, it's not pasted on there. But you can see that the data is there on the notes. So we have it. Okay. I'm going to kind of cheat here and use what I have to enter this onto my notes. It should just copy and paste. I'm not sure why it didn't do that. But here is the bar chart, the frequency bar chart, and you can clearly see the labels. And then if we want to change that to a pie chart, we click here from bar chart to pie chart. Again, keep it as the relative frequency, and notice it makes it for you. So we don't really need to worry about the percentages. But again, I'm going to just talk about those real quick. Actually, I'm not going to do this. Let's see if this will. Let's see, copy image. Will this go on there? I love technology, right? Of course not. So here's my pie chart. And again, what are these categories broken up into? And that would be the relative frequency. So when we're looking at this from the data that we already had and we did yesterday, just understand that when we're dealing with a pie chart, how would I get these angles deals with the actual relative frequency of each piece. This right here, if we go back to that website, it gives us our relative frequency. That was 52.5%. So if we had to make our own pie chart to find this angle, I would take 360 and multiply by 0.525. That would be 52.5%. And that would give me the angle to enter this. Okay, so you can see that it looks like it's a little bit over 180 because that's more than half the circle. So if we had to do that on our own, that's how we would do and find these angles. And we'd have to use a protractor to write out each angle. We don't have to do that. We have the technology to use it, and that's what we're going to continue to do. Okay, so here's the pie chart displayed, and here is the bar chart. Okay, so the next thing is a side-by-side bar chart. Okay, so a bar chart can be used to compare the distribution of a category variable in two or more groups. Okay, however, we're going to use relative frequencies, the percentages or proportions, especially if the groups have different sizes. So this is where we can show, you can see that this is broken up into two groups, female and male. Now, it doesn't tell how many of each there are, but you can see that the relative frequency or the percentage of each is shown. So blue being female and purple being the male. And you can compare and analyze the data. So if we look at an example here, it says a survey asked first-year college students, how many miles is this college from your permanent home? Okay, students had to choose from the following options: 5 or fewer miles, 6 to 10 miles, 11 to 50 miles, 51 to 100 miles, 101 to 500, or more than 500. The bar chart shows the percentage of students at public and private four-year colleges who chose each option. Compare the distributions of distance from home for students from private and public four-year colleges. So we want to look at the distance from home for private and public, and we're going to compare those. So you can see that public schools under 50 miles are actually closer to their home. When it comes to private schools, once we get above 50 miles, you can see that the private school students are further from their home. Okay, so again, you can write this however you want, but the conclusion that we could write from this data, is students at private schools, or four-year colleges, I should say, private four-year colleges travel a farther distance from home. Than students at public four-year colleges. So once we have the data, you see here we can analyze it, and it clearly shows that the further away from home, there's more private school students. And we could get into a whole nother set of data as why is that usually costs more money to go to school out of state. So we'd have some inequality there with finances. Usually students that are a little bit more well off can afford to go to private schools out of state. So that's the last example for 1.2. Again, good luck on your homework. If you've got questions, make sure that you're asking me. Once you're done with these notes, you can go right on to the homework.